You guys are serious troopers sticking with me through these operations on rational expressions. In this video, you should be able to add and subtract rational expressions by the end. We're going to start with some rational numbers, adding first, and then look at rational expressions addition, then subtracting rational numbers, and finish with subtracting rational expressions. Then you guys will all be pros. All right, adding rational numbers. When we have common denominators, common means they're the same. And when they're the same denominator, that makes our job much easier here. We can just take our numerators and add those together. 4 plus 1 is 5, and the denominator remains the same, 7. That's nice, but in a case like this where we don't have common denominators, we have to do some work. And in this case, we have to multiply one of the fractions by some number so that they have a common denominator. The only number we can multiply a fraction by so we don't change its value is 1. However, we do multiply it by a special form of the number 1. And what we notice is that if we take 4 and we multiply it by 2, we get 8. And so that's what we're going to do is we're going to take this 1/4 and we're going to multiply it by 2 over 2. That way we will have a denominator of 8 and a numerator of 2. So this 2/8 is equivalent to 1/4, and we get it by multiplying 2 times 1 is 2, and 2 times 4 is 8. So we've just changed the way the fraction looks. We haven't really changed its value, and we are now adding that to 6/8. And when we do that, we can now take the 2 plus 6 is 8, and the denominators are common now. They are 8, so it stays 8. And now we have this fraction of 8 over 8, which is 1. So that's how we are going to be adding rational numbers. Now, sometimes we'll need to multiply both fractions by some form of the number 1. In this case, we didn't need to. In general, we can think of adding rational numbers in that way. So here I'm going to multiply by d over d, and I'll get d times a over d times b. And then we're going to add to that, and we're going to multiply this c over d by b over b. So notice that what I did is I took that denominator from this fraction and I made a special form of the number 1 and multiplied that by the other fraction. So we'll get c times b over d times b. Now notice that we have common denominators of db in both fractions. So now we can add them. So we get dA plus CB over DB. And that's just a way to think about this stuff, but it's nothing you need to memorize. So now, when we have these polynomials in the numerators and denominators of fractions, we have a common denominator here in the first one. And so we can just add the numerators. 3x plus 4x is 7x over common denominator is 7x squared. And the 7's make a 1, and this x is going to cancel with one of these x's. So we'll get x to the first. So the resulting fraction is 1 over x, and that is a rational expression as well. When we have a situation like this, where we do not have common denominators, it gets slightly more messy. So we have to take our denominator from this fraction and multiply it by this fraction over itself. So that x plus 7 is going to be in the numerator and the denominator. So we can only multiply by a special form of the number 1. And then we take this denominator and multiply it by this one. So we're going to multiply this by x minus 4 over x minus 4. And notice in this one I did one big set of parentheses, and this one I did a set on top and bottom. Doesn't really make any difference. The result, however, is going to be a big pain in the butt. We're going to have to take the two binomials here and multiply those, and the two binomials there and multiply those, and then we'll have to add the result of each. So x times 3x is going to be 3x squared. X times negative 5 is negative 5x. 7 times 3x is 21x. And 7 times negative 5 is negative 35. So that was from doing FOIL on these. And now we're going to add to those. So I'm going to put that in parentheses and add to those the result of FOILing over here. So we will get negative x times x is negative x squared. Negative x times negative 4 is positive 4x. 1 times x is 1x, or just x, and 1 times negative 4 is negative 4. Now all that is in the numerator, and in the denominator we just have the binomial x plus 7 times the quantity x minus 4. Continuing on, we're going to take these two trinomials and add them together. So we have 3x squared plus a negative x squared is 2x squared. Negative 5x plus 21x is 16x. So I'm taking these and I'm combining those. And so that 16x I'm going to add to 5x. That's going to leave me with plus 21x. And then minus 35 plus a negative 4 is going to be minus 39. And all of that is over the quantity x plus 7 times the quantity x minus 4. Now the numerator here, that's not going to factor. So there's nothing I can do to try to get rid of any more terms, and that's the end of that problem. Now this video is already running pretty long, so it must be joke time. Why was the equal sign so humble? Well, he knew he wasn't greater than or less than anyone else. All right, so subtracting rational numbers. If you stick with me, I'll give you one more joke before this video ends, but that really keeps a bunch of you here. All right, when we have common denominators, this is really just like adding, except for we're going to subtract across the numerators. So we have 3 minus a negative 2 is going to be 3 plus 2, or 5. And the common denominator remains the same, 11. In this next one, I can see right here that if I take that 5 and I multiply by 2, I'll get 10. So I'm going to multiply this by 2 over 2. And so I'll have that 7/10, subtract, and then 1 times 2 is 2, 5 times 2 is 10. Now that gives me my common denominator, and I can do 7 minus 2 is 5, and 10 is the denominator. Now thinking about subtracting fractions in general, we can take the denominator of d and we'll multiply this fraction by d over d, and then multiply the other fraction by the denominator over itself, b times b. The result then will be dA over dB minus CB over dB, and that then will be dA minus CB over dB. All right, so looking at rational expressions and subtracting them, when we have a situation where the denominators are the same, we can just subtract the first polynomial from the second one. So 3x minus 4x is negative x over 4x plus 1. You've stuck with me. We're in the home stretch here, and so a joke is coming your way. Maintaining the theme here. The other day I had an argument with a 90-degree angle, Turned out it was right. So we need to take our fraction and multiply here by x minus 9 over x minus 9. That comes from the denominator here. And then this denominator, we're going to use that one over on the other side. So we're going to have negative x plus 3 over negative x plus 3. Notice that we're multiplying by 1. That's really key here. Using FOIL up here, we have x times 2x is 2x squared. X times negative 5 is negative 5x. Negative 9 times 2x is negative 18x. And negative 9 times negative 5 is positive 45. Now I'm going to take all that and I'm going to subtract the result of foiling this. X times negative x is negative 2x squared. X times 3 is positive 3x. Negative 3 times negative x is positive 3x. Negative 3 times positive 3 is negative 9. And all of that is going to be over the quantity x minus 9 times the quantity negative x plus 3. Let's see what we get when we start looking at common terms. We have 2x squared minus a negative 2x squared is going to be a positive 4x squared. Negative 5x minus 18x, that's negative 23x. So we have a negative 23x, and we're going to subtract 6x. So negative 23 minus 6 is negative 29x. And finally, 45 minus negative 9 is going to be 45 plus 9, which will be 54. All of that is over the quantity x minus 9 times the quantity negative x plus 3. The numerator there turns out not to be factorable, and so we are done. Great job sticking with me. You guys are the best. Hope these all make sense to you and that you now know how to add, subtract, multiply, and divide rational expressions.